Welcome back to another video. Today we are going to be looking at Pythagoras' theorem, normally referred to as Pythagoras. We can use Pythagoras whenever we are given a right-angled triangle with two sides. The formula is a simple one to remember. A squared plus b squared equals c squared. Another way of saying this is our two smaller sides when squared and added together give us the longer side squared. There's only one side that we need to ensure we label correctly, and that's side C. Side C is always opposite the right angle, also called the hypotenuse. This is always the longest side of a triangle. We are going to look at three different examples today. Our first example is when we are looking for the longer side. Here we have a right-angled triangle with lengths 8 centimeters and 14 centimeters. First, we want to label all the sides of our triangle. Opposite the right angle is C, and the remaining two sides can be labeled A and B. It doesn't matter which order we put A and B. Writing out our formula, a squared plus b squared equals c squared. Now we can substitute in our values. We know A is 8 and B is 14. This gives us 8 squared plus 14 squared equals c squared. Squaring both our 8 and our 14 gives us 64 plus 196 equals c squared. Adding 64 and 196 together gives us 260 equals c squared. Since we have c squared but we want c, we must square root both sides. That gives us 16.12 for c, meaning that our answer is 16.12 centimeters. Now let's have a look at a question when we know the longer side and are looking for one of the smaller sides. It is important that we start this question like any other question. We label the side opposite the right angle as C and the two shorter sides as A and B. Writing out Pythagoras as a squared plus b squared equals c squared. Substituting the two values we know, b being 3.1 and c being 5.1, gives us a squared plus 3.1 squared equals 5.1 squared. Again, like before, let's square our numbers. Doing this now makes it easier to work with since we no longer have any squares. 3.1 squared is 9.61 and 5.1 squared is 26.01, giving us a squared plus 9.61 equals 26.01. This is where the example differs from the last. Our numbers are on different sides of our equal sign, so we need to bring them together. We do this by taking 9.61 away from the 26.01. If we do this, we get a squared equals 16.4. Now, like before, we square root our answer giving us 4.05, so our missing side must be 4.05 centimeters. Finally, let's have a look at a complicated question. Here we have been given two triangles that share a common side. Whenever we are given a common side, it is more likely than not that we are going to have to work out that length. Let's highlight the two triangles to make things easier. Now we can see we are looking for the longer side of the green triangle. However, we only have one length, but we need two. Lucky for us, it shares a common length with the blue triangle, which has two sides. So let's find the missing side of the blue triangle. For this, we are going to be using Pythagoras, which is a squared plus b squared equals c squared. Labeling our triangle C as our 18 centimeters and A as our 9 centimeters. Substituting these into our formula means we have 9 squared plus b squared equals 18 squared. Squaring our numbers, we get 81 plus b squared equals 324. This is now looking like our second example, which means we must take away 81 from 324. This gives us b squared equals 243. Now we need to square root the 324, which gives us 15.59. We can now add this onto our diagram. Looking at the green triangle, we now have two lengths, which means we're on our way to finding x. Writing out our formula, we have a squared plus b squared equals c squared. Let's label our triangle. Our x is our longest side, so we are going to label this as c and the remaining two as a and b. Substituting 15 in place of a and 15.59 in place of b, we get 15 squared plus 15.59 squared equals c squared. Squaring our numbers gives us 225 plus 243 equals c squared. Adding 225 and 243 together, we get 468 equals c squared. Square rooting 468 gives us 21.63. meaning that our missing side is 21.63 centimeters. Again, thank you for watching our video. We have another video available on 3D Pythagoras, so make sure to check that out.